No, perdón. No tengo perdón. No tengo perdón. Tienes razón. Tienes razón. Sí. Estaba muteado. Estoy haciendo un gran esfuerzo para mostrar cómo viene viniendo mi voz. Y ustedes se ríen de mí, ¿eh? No, no, mute. Gracias. No, no, ahora sí te escuchamos. Dice, bueno. Hoy me levanté mucho mejor de la voz. De ánimo como siempre. Es increíble. Los medicamentos que estoy tomando me producen insomnio. Duermo 3. Anoche dormí 5 horas. Pero hay una cosa. Nunca me pasó. Me despierto y es como prender la luz. Salto en la cama. No tengo pereza, no tengo nada. Eso es lo caso esto. Los nervios capaz sí, ni que hablar, ni que hablar, ni que hablar. Empezamos, ¿no? Bueno, nave de carga de SpaceX, cargo Dragon 2. SpaceX no fabrica más estas naves, está jugada 100% al Starship. Igual de todas maneras, obviamente si necesitan la pueden hacer, saben cómo hacerlo, ¿no? Vamos a poner lo que está transmitiendo NASA en este momento. Estoy sin cam, tengo que poner la cámara derecha, así que ya vengo. Se cayó la cámara. Cambié el fondo de pantalla, ¿vieron, no? Vamos a poner un poquito de música mientras, así no quedamos sin nada. esa cantidad de mensajes.
Dragon is in countdown. Falcon 9 is in startup. Dragon, SpaceX, go for launch.
Bueno, esperemos que no me baneen por esto, ¿eh? Vamos a ponerlo de otra manera. A ver.
And food for the astronauts aboard the International Space Station. Good evening, and thank you for joining me for live launch coverage of CRS-25. I'm Megan Cruz. You just saw Falcon 9 and Dragon on Launch Complex 39A here right behind me at Kennedy Space Center. Fueling began about 10 minutes ago, and we have an instantaneous opportunity to launch at 8:44 p.m. Eastern. Aboard the space station right here over the last 21 years. Today, more than 24 experiments, including some that will study Earth's climate, are packed away in Dragon awaiting launch. Let's go now to SpaceX headquarters in Hawthorne, California, where we have Shiva Bharadwaj to tell us more about this mission, which Shiva, NASA and SpaceX were initially targeting last month for launch.
Thanks, Megan. It's great to be covering today's mission in partnership with NASA. And like you just said, we spent the last few weeks working through an issue on Dragon after teams discovered a small vapor leak. Since then, we've completed thorough inspections and replaced the components that could have been degraded by exposure to this vapor. And we've been working hand in hand with NASA throughout the process. And now we're ready to launch. This year also is the 10-year anniversary of Dragon becoming the first private spacecraft in history to visit the International Space Station, deliver cargo, and then return to Earth. 5 years ago was our first reflight of a Dragon on the CRS-11 mission, and since then we've made 31 flights to the space station with 14 reflights of Dragon. Today's mission adds to that tally and will mark SpaceX's 30th launch of 2022. It'll also mark our third Dragon flight this year, following the crewed launches of Axiom 1 and Crew 4 back in April. Now on screen is our Falcon 9 rocket and the Dragon spacecraft sitting at the very top. The capsule flying today is our first third flight of a new cargo Dragon, which previously supported the CRS-21 and 23 missions last year. Now this version of Dragon is certified for up to 5 flights, and it'll be joining the Crew 4 spacecraft, which is currently docked at the station. Moving down is our Falcon 9, our reusable 2-stage rocket. It's actually 2 rockets in one. That lower part is called for its 5th time, and as that name suggests, Falcon 9 has 9 Merlin 1D engines at the bottom of the first stage. They are what accelerate the vehicle through the Earth's atmosphere and to those various orbits in space, and we've got a great photo of those 9 engines before we roll them out to the pad on Tuesday morning. We're going to be attempting to recover this first stage on our drone ship named a Shortfall of Gravitas.
No estaba saliendo mi voz, increíble, no sé qué pasó. Pero bueno, estaba contando un poquito justamente, bueno, dónde va a aterrizar el cohete, el tipo de nave que era. Bueno, acaban de cargar recién completamente de combustible en las 2 etapas.
Sounds good, Shiva. Thank you. In addition to SpaceX, NASA teams both here in Florida and Houston are monitoring today's launch. You'll hear from Sandra Jones, who you see in there inside with Mission Control in Houston. But first, let's check in with Daryl Nail, who's monitoring the launch team here at Kennedy. Daryl.
Yeah, thanks, Megan. Everything looking good so far here from Hangar AE at the Space Force side of things. You can see behind me the data and telemetry flow through this building. We're happy to be here and appreciate them having us here. Out to the rocket we go, and you can see it is twilight here on the east coast of Florida at historic Launch Complex 39A. You can see the rocket is being tanked. The launch director gave it a go around 8:06 p.m. for tanking to begin, and RP-1 is now flowing into the first stage and the second stage, along with the liquid oxygen, which you can see along the rocket the center part of the first stage. You can
Y
kind of see
tuvieron
the
que
fill line. Where's
demorar,
that?
inclusive
That's the part
cambiaron
that's chilling.
uno de los
We do have a
paracaídas del
small
ingreso.
issue with the weather. We're currently
Por las dudas.
70% go, but the launch weather officer for the Space Force
70% go.
briefed the
Mira el tiempo,
SpaceX's
mira el
launch team
clima.
about this right here. And you can see this is some weather imagery that we have here. Storms
Alex,
are
¿qué tal?
bubbling up
Gracias.
really heavy along the center part of the state. You can see it's all pushing to the west, which is good because there's some easterly flow. However, the Space Force is able to monitor what's called an outflow boundary that is coming back to the east and is scheduled to be here at the launch site right around T0. So, as you can see from the graphic on your screen, they're holding the percentage go at 70%. Normally this time it would be a little bit higher, but they're going to hold it at 70%. Concerns are cumulus cloud rule and flight through precipitation. Winds are 15 to 20 miles per hour. Other than that, we're looking good to go. And let's head out to JSC in Houston.
18 minutos.
Join Sandra for more.
Good evening. I'm NASA's Sandra Jones here inside the International Space Station Flight Control Room at the Johnson Space Center in Houston, Texas. Mission Control Houston is the nerve center for space station operations and
Este
our
es
flight
el
control
nervio de las
on
operaciones.
console and ready to
Es
support today's
el
cargo
lugar
launch.
central.
Leading the team in Mission Control during today's launch is NASA
Gracias,
Flight
José,
Director Scott
gracias.
Stover. You see him there on your screen
Esta
right
nave fue
there,
la
and
primera
when
de la
Dragon
segunda
arrives to the
generación,
International
dice
Space Station on Saturday, it will dock to the
Alex, de
station.
Lanzamientos Espaciales. Pongan su página como favorita, lanzamientosespaciales.com.
will be on tap to monitor that approach. Dragon is slated to spend about 1 month attached to the International
Un mes va a estar esta nave de carga a bordo.
returns to Earth with research and return cargo and splashes down off the coast of Florida. For now, everything continuing to look good on the station side for today's launch, so back over to you, Megan.
Thank you to both Sandra and before that, Daryl. We are now about 17 minutes and counting from liftoff of CRS-25. Let's check out some of the science flying on this mission.
Nos van a mostrar un poco de lo que va de ciencia. Células inmunes, un espectrógrafo, tejido vivo y docenas de experimentos. No puedo creer que locura España. Camilo dice eres luchador. Sí. ¿Sabes una cosa? De lo que he hecho toda mi vida, digo, no. A veces la gente no se imagina lo que es vivir en un país pequeñito como Uruguay, en el medio de dos gigantes, donde las oportunidades realmente son pocas y donde hay que hacer de todo. Muchos saben, soy piloto, soy controlador de tránsito aéreo, trabajé de piloto, pero trabajé de muchísimas cosas más. Vendí bizcochos en la feria, trabajé de taxista. Y no es que ni me lleno la boca, ni me complica. El trabajo es lo que haya que trabajar. El trabajo. Luca dice, vuelve la moda de macho alfa. Harker le dice, ¿cómo sigue Daniel? ASMR, hacemos ASMR, sí, sin drama.
Direct observations of the minerals in these dryland regions to advance the science of how mineral dust can...
No lleva personas, solo carga, absolutamente, solo carga. Creo que lleva 2,5 toneladas de carga.
Arid regions, when you have dust storms, you can see a dust storm in Africa.
De piloto, conductor de auto, no, al revés.
Particular to understand.
Un día les cuento la historia de mi vida, pero fue primero taxista, luego hice curso de piloto, empecé a aprender eso paralelamente. También trabajaba soy técnico en electrónica, trabajaba como técnico en electrónica, pero en la aviación, haciendo mantenimiento e instalación de equipos de navegación aérea. Siempre hice más de una cosa junta.
Yeah. So Kate, it sounds like
Hubo un momento que obviamente tuve que dejar el taxi para pasarme al taxi aéreo. Ahí manejaba aviones y llevaba pasajeros a aeropuertos, a estancias. Tanto había una negocia, no sé, a Porto Alegre, a San Pablo. Ahí como iba y aterrizaba en una estancia en una pista de tierra.
Light sheets and much more. And once EMIT is put onto the International Space Station, it'll join that fleet.
Wow. And I do know that it's not just what we have orbiting the Earth. There's also a lot of research being done on the ground. So when you consider this whole portfolio of climate research that we're doing, how will this help us address climate change?
Well, the more we know about the planet, the more we can use that to provide
O sea que sabes si te la rejas negra, dice.
and the public about what's happening on
No,
Earth.
en aviones trabajé solo en 1 o 2 aviones que eran propios del sitio donde trabajaba como técnico, instalando cosas muy específicas para el trabajo que hacíamos, que es inspección en vuelo. Inspeccionábamos los equipos de tierra con ese avión, y ahí trabajaba de otra cosa más, como operador de teodolito para la inspección en vuelo. Me están haciendo acordar de cosas que he hecho. Es más, tuve la suerte de poder operar, o sea, de trabajar con el primer radio teodolito de segundo, precisión de segundo, en mi país. El radio teodolito era algo, en ese momento podía medir milímetros, no había GPS, no existía nada de eso, la cinta métrica nada más. Tener una precisión de 1 segundo de grado y 1 milímetro con un distanciómetro electrónico infrarrojo era como mirar la luna.
Now, after separating from Falcon 9, Dragon will autonomously make its way to the International Space Station using its navigation sensors and its engines. The capsule has 16 Draco engines, which are used to get the spacecraft from one place to the next.
16 Draco tiene la cápsula esta para maniobrar y llegar a la estación espacial. Ahí se ven las salidas. Esto acá.
These forward bulkhead Dracos are primarily used for high thrust maneuvers like the orbit changes that we'll need to get to station and eventually in about a month to get back home to Earth. Each of those thrusters are capable of generating about 90 pounds of force in the vacuum.
Camilo dice, mereces estar,
The service section Dracos are used
ahí vemos
primarily for
que increíble los Draco en acción.
to the space station. You can actually see them firing.
Esta la vimos en vivo, en directo. Estas imágenes son de las mejores que he visto de ellas.
The orbiting laboratory. And just like those Merlin engines on Falcon,
Hoy 7 grados había en Montevideo en la mañana.
The Draco thrusters once that spacecraft returns to Earth. Dragon and Falcon continue to remain in good health and we're ready to support
con 8 de backup,
on-time liftoff
correcto,
around
Artemis,
8:44
sí.
p.m.
Es lo que tiene que algunos eventualmente fallan.
And 2 people very excited about today's launch are right here next to me. We have Claire Green and Benjamin Whitfield, both of Arkansas State University. They actually have an experiment on board and are about to tell us about it. Great to have you here.
Nice to be here.
All right, you're so excited. I love it. So let's take a look at the screen. We have some pictures of when the team was here earlier, a couple of weeks ago, and you guys were prepping your experiment. What are you guys studying?
So we are studying waxworm larvae and their unique ability to break down thin plastics, thin plastic bags, into a non-pollutive byproduct. And we're very curious to see if they could still do this process in microgravity or aboard the space station.
Yeah, so we know that this happens on Earth. Why do you want to see if this happens in microgravity?
Well, the application of breaking down plastics is beneficial anywhere. It's a problem that we're learning how to deal with. So if we can learn how to deal with it on Earth and in the space station, then we can extrapolate that to other environments.
Why are you guys interested to see how this will react in space? Is it because we as an organization, NASA, we are thinking about going farther than we've ever been before?
That's exactly what it is we are proposing this as a long-term space travel waste management system, because plastic, it's lightweight, it's cost-effective, it's not going anywhere, and we don't want a pollution problem like we've had on Earth.
Yeah, perfect. So I know that this is the first launch for both of you. Why don't we take a look around really quick? So there it is on the launch pad, Falcon 9 and Dragon. Inside Dragon is your experiment. How are you guys feeling?
It is surreal. It is, it feels like a dream, and it's about to be a dream come true, not just for myself and Claire, but for our whole team, for students at Stanford who also have an experiment going up, and for all the students who assisted us in our citizen science.
Perfect. Guys, I cannot wait to see what you discover. Thank you so much for your time, and I hope you enjoyed the launch.
Thank you so much.
And we have another student experiment on board Dragon today. These guys are in college, but we have a high schooler here. You see Celine Coquelar. She won the annual Genes in Space research competition by designing a new method of detecting water contaminants. If successful, her work could be used to test water quality both in space and also remote parts of the Earth. Genes in Space is made possible through Boeing, a startup called Mini PCR that makes equipment for biology research, and the ISS National Lab. All right, we're just under 6 minutes till 6:56. I am having a hard time, guys, but we're close to terminal count. So let's bring back Jimbo live from SpaceX headquarters in Hawthorne, California, and Daryl here on Florida Space Coast to watch the final moments of the countdown. Guys, take it away.
Porque quieren tener protagonismo.
Thanks, Megan. Now, the SpaceX team is not working any significant issues with both Falcon or Dragon at the moment. And the weather, I hope, is continuing to trend well. Like Daryl had mentioned earlier, we're keeping an eye on some clouds and potential precipitation. And we're going to keep
Gracias, señor director, por poner el
make
cohete.
sure we remain go for launch. The range does remain go for launch at this time. Now, at this point, the rocket propellant 1 fuel is completely loaded on the second stage and nearly fully loaded.
Y a ver cómo se me escucha.
Liquid oxygen loading is underway.
Javier Héctor Parola dice buenas noches. Lucas Quiroga, de Mendiolaza, hace años, menos 2 grados hoy en Mendiolaza. Primer miembro VIP, Ana Gabriela Jiménez, que saluda en el chat. Rosana Chávez, Fernando Castañón. Oli, un beso, gracias.
Make sure
Ricardo TG.
SpaceX performs an engine chill. This happened.
Fernando Castañón de nuevo.
Has happened.
Lucas Quiroga.
7 minutes. Flowed a small amount of the super chilled LOX.
Rodolfo Gallegos.
Turbo pumps. And this is done to avoid a thermal shock.
Freddy Martínez, para evitar que verte mejor, Dani, decía. Dormía poco antes.
Dragon began
en cuenta interna el dragón ahora en este momento. Brindarte mejor, dice Pablo. Gracias a todos, un placer compartir un momento con ustedes. Roberto, que te recuperes pronto. Cuenta interna el dragón, Bueno, ahora el brazo que lo agarra se abre la grapa esa y se retrae para dejarlo libre para el lanzamiento. Esto pasa ahora.
And then shortly after that, the whole structure will pull away from Falcon 9. Now, in these last few minutes, Falcon 9 is performing a set of final health checks on its primary communications, avionics, and
Claudio Beltré, sigo los saludos.
for liftoff.
Alex de Lanzamientos Espaciales, Juan Pablo Guardia, Chetti, Javier Capuchetti de Argentina, gracias. A Chinet también, de Canarias, Rodolfo Gallegos. Fake Taxi dice. Con Daniel, no.
Cooling of the Florida air around the second stage, and shortly after we'll see the white truss structure on the right.
Aquí estaremos siempre que sea posible, disfrutando del lanzamiento junto con ustedes y disfrutando del anfitrión. Gracias, mil gracias, en serio. Poner una sonrisa en la cara aparte. Bueno, estamos con lanzamiento de SpaceX, FALCON9, cohete de 2 etapas, 70 metros de altura, no sé cuántas, 100 toneladas, 200, más 500. Estoy hablando sin leer nada. Varias toneladas de carga que van a la estación espacial. En esa nave, cargo Dragon 2. Estamos muy próximos a que la nave esta sea autónoma, el cohete sea autónomo en el lanzamiento. Al minuto pasa a ser totalmente autónomo. 70% del viento de condiciones atmosféricas para el lanzamiento. Pero lentamente van a lanzar. Auriculares, es el momento. O avisarle al vecino que van a subir el volumen. Yo soy tu padre, le dice, pero no me hagan decir esas cosas. Desert pregunta, ¿qué es ese humo? No es humo, es el oxígeno líquido que se usa para la combustión, que escapa por la válvula de sobreflujo. Al entrar en contacto con la atmósfera, produce ese efecto que parece humo. Gracias, Lucas. Gracias, Lucas Quiroga. No se olvide de sus likes, dice Ricardo TG. Y ahora sí no hablo.
Dragon is an auto idle.
Around Falcon 9.
Yeah, you sure can. And just a few minutes left in twilight. A little bit of illumination makes it nice. At T-minus 1 minute, Dragon will transition to internal power. Falcon 9 computers will enter startup mode and begin final pre-launch checks, guiding the rocket through the last seconds before liftoff.
Bueno, en startup, ¿qué significa? Que está en modo arranque.
Falcon 9 is in startup.
There you have the call.
Dragon is in countdown.
Both stages are now pressurizing for launch.
LD is go for Falcon 9, CRS-25 launch.
So range is go, weather is go.
T-minus 30 seconds.
It's a beautiful time of day to watch this launch if you're out on the beach.
T-minus 15.
And here we go.
12 segundos.
9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
Impresionante.
Power
flight, successful liftoff from the Kennedy Space Center, Launch Complex 39A. Falcon 9 is heading towards its next major milestone. That's for the point of highest stresses that the vehicle will experience during ascent. There's the call out for maximum dynamic pressure. So from here, the stresses on the vehicle will get lower and lower as we raise our altitude. Coming up, we've got 5 events back to back. The first of those will be main engine cutoff, or MECO. That's where all 9 Merlin 1D engines on the first stage will shut down. Following that will be stage
¿Qué es el Max Q? Es la máxima resistencia aerodinámica. Mire qué imagen, qué imagen.
We'll flip around to make sure it's headed back towards the landing site, and our drone ship named Shortfall Gravitas. And then the second stage will ignite its Merlin vacuum engine to boost Dragon into low Earth orbit during second engine start number 1. We just heard the call out there for engine chill-in on the second stage engine starting.
Mire cómo se abren esas llamas, porque cada vez es menos eficiente con la altura. Su motor Merlin.
Prepare for atmospheric entry. Now, all of those events happen over about 45 seconds, and again, they are followed by stage separation, first stage flip, second stage.
Por eso es que ahora apagan estos motores, estos 9 motores, y encienden, se separan, y de ahí viene, y el corte de motor se llama MECO, en inglés, es la sigla.
MECO. Stage separation confirmed.
Fantastic sight.
And back startup.
So the first 3 of those events are complete.
¡Qué imagen! A la derecha. ¡Qué impresionante!
And now the boost back burn is underway. The shot on our screen right now is of the Merlin vacuum engine on the second stage. And as this view toggles, you may catch the first stage. It is firing.
Tenemos ahora doble imagen, cada una de las etapas. La que sigue subiendo, que empujó todo por inercia, pero va a caer. Y la que se va al espacio con la carga, que es la de la derecha. Y acá abajo mío está la telemetría justamente de esta de acá arriba. ¿Sí? Bueno, esta sigue a fondo para poder colocarla en órbita. Mientras vemos el booster de allá, de aquel lado, que está abriendo las rejillas, preparándose para cuando deje de subir por la inercia y empiece a bajar. ¿Cómo sabemos cuándo baja? Mira la altura, 106 dice. 2900 la velocidad y 106 kilómetros, 107. Aumentó 1, está subiendo. Todavía está subiendo. Miren la velocidad. 2959. 2960, 62, 63. Sigue aumentando la velocidad. ¿Por qué? Porque ahora baja. Eso bajar. Por eso aumenta. Miren la altitud, 106. Vamos a seguir ese reloj. 106, 105. Está bajando. ¿Se dan cuenta? Es re fácil interpretar estos números. Es como cuando uno tira una piedra al aire, sube, 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 llega un momento que empieza a bajar. Esto es lo que pasa. Cuando llegue a la mitad de la distancia, va a encender 3 motores para desacelerar. ¿Por qué desacelera ahí? Bueno, porque aprovechan la atmósfera para seguir desacelerando luego. Empieza la parte dura de la atmósfera, entonces le conviene estar por el perfil con 2000 y pico kilómetros por hora menos. Igual viene, llega cuando está a muy poca altura, está a más de 1000 kilómetros por hora. ¿Por qué hace eso? Porque tiene que llegar con mucha velocidad cerca del piso. Porque los motores Merlin son demasiado potentes y no puede reducir el acelerador a 5%. Creo que es un 50 o 60% nomás. Si no viene rápido, en lugar de aterrizar, sale volando otra vez, porque aparte está vacío. Bueno, el director de vuelo acaba de decir que apagaron ahora en el booster el sistema de seguridad de explosión. Y ahí vemos el encendido. ese sentido, miren la velocidad. Miren cómo bajó, ya bajó 1000 km por hora.
Bottom left-hand side of your screen, rapidly slowing down as we fire the entry
Bueno,
burn.
y ahí tenés
That burn only lasting about 15 seconds.
50 segundos. Alcanzó para desacelerar.
And that entry burn and the plume coming back on the stage ends up depositing a small layer of carbon on the vehicle, which is what gives our first stages that awesome sooty look once we've reflown them.
Interesante explicación, dice Michael Lozano. Es lo que se me ocurrió, No estaba guionado esto.
And they'll deploy just prior to landing during the landing burn. If we're successful in recovering this Falcon 9, it'll mark its 5th successful landing and our 130th
Sónico,
landing.
¿qué quiere decir? Está pasando por la velocidad del sonido. 6 kilómetros de altura. Se viene el aterrizaje. A ver si lo podremos ver. Miren estos 1000 kilómetros. 4 de altitud. 4 kilómetros, 1000 kilómetros por hora. De locos. Ahí encendido para aterrizar y abre el tren todo junto.
We're going to see that come all the way down to 0. On the right-hand side of your screen is our drone ship. And also keep an eye out on the left-hand side of your screen for landing leg deploy.
Se viene la apertura del tren ya.
Stage 1 landing leg deploy.
Ahí abre el tren. No, qué imágenes.
People really excited behind me. Right in the middle, 5th landing for this Falcon 9, 130th landing overall for an orbital class rocket. Beautiful sight to see.
Impresionante, impresionante.
Is second engine cutoff number 1 or SECO 1.
Bueno, viene el corte de motor ahora. Esta etapa que sigue, miren, 198 kilómetros y está acelerando. En 2700. Tiene que tener 27 para estar en órbita.
After we complete second engine cutoff number 1, we'll do a quick check to make sure that the burn performance is as expected.
Stage 2 FPS.
We're in the targeted orbit. We usually hear that called out as a nominal orbital insertion or a good orbit call out on the loops.
Apenas apague, el director de misión va a decir si lo insertaron bien en órbita o no. Ahí está perfecto. Y esperemos el aviso.
So you heard a call out on the loops there for shutdown of the Merlin vacuum. There's nominal orbital insertion. So that means that the ground teams have assessed.
Bueno, no escuché el director, pero dice que sí. Inserción nominal.
That means that Dragon is right where we want it to be since it's been riding on the first stage, the second stage this whole time. Now, if you're just joining us, we're about T+9 minutes, 20 seconds into the mission. On to the screen next to me is a view of the Merlin vacuum engine with Earth behind it on the second stage. Now, the second stage has one major task remaining, that is commanding separation of the Dragon spacecraft.
Bueno, se viene ahora la separación en unos
We're
minutos.
hoping to have video of separation from the top of the second stage. We actually got a quick glimpse of it before.
Dice que esperan tener video al momento de la separación.
Of Dragon and gives us a
Recuerden que ahora la Dragon está en órbita, pero está todavía agarrada en la segunda etapa. Tiene que soltarse. Tiene que abrir el cono para poder utilizar sus motores.
Crew 4 vehicle capsule Freedom, which is currently on orbit, so we'll be back to dual Dragons docked at the International Space Station.
Y mucha gente pregunta, ¿qué pasa con esa etapa 2? Se descarta. Esa etapa 2 la hacen girar, ponen el motor hacia adelante, hacen un gran encendido, frenando. Y obviamente si no tiene velocidad orbital, regresa y se quema.
More than 5,800 pounds of science, research, crew supplies, as well as vehicle hardware to the orbiting lab
Más de 2
and its
toneladas de
crew.
carga. Puede confirmar.
And amazing, more views inside the trunk. Now, at this point, the second stage is performing its final checks to ensure that we're not imparting any unnecessary momentum or spin
Me pregunta si estamos en
to
vivo.
the Dragon spacecraft. Once those calculations are complete, Dragon and the second stage will command separation. And shortly following separation, Dragon will conduct a series of health checks on its thrusters, its cabin, thermal, and solar systems.
Alguien en el canal dijo un día hace un tiempo, y me quedó la frase, esta gente hace que lo rutinario parezca, o sea, que lo difícil, lo imposible, parezca rutina, parece cosa todos los días.
Got about 30 seconds to go.
En 30 segundos de separación, estamos mirando adentro. Esa es la parte de adentro del compartimiento de carga que es abierto. Estamos mirando la cápsula por atrás, donde vemos la pollera, o sea, esa parte donde están los paneles solares, es abierto las otras. Esto es lo que se ve. O sea, es un lugar de carga no presurizado.
Dragon separation.
Ahí se va. Confirmado.
Phenomenal. So with that, CRS-25 gently floating away from Falcon 9
tenemos
to the
ovnis,
second
montones,
stage.
para los
Again, coming up next, we've got
conspiracionistas.
service section Draco checkouts, as well as nose cone opening. But that's actually going to complete my coverage here from Hawthorne. So I'm going to pass it over to Sandra at Houston.
Bueno, dice ahí termina la cobertura de Hawthorne, California, y pasan con Sandra. Vamos a ver qué dice Sandra en Houston.
And thanks, Shiva. Welcome back into the International Space Station Flight Control Room. That was a beautiful launch from here in Mission Control Houston.
Wow, eso Draco.
Standing by for confirmation of the nose cone deployment.
Repetimos un poquito que justamente está.
And we did just get
Uy, Ariel Space,
that the nose cone was successfully deployed. That nose cone does cover the docking hardware,
qué locura.
rendezvous sensor, and the 4 forward bulkhead Dracos. The nose cone will stay open until the end of the mission, until after deorbit burn and just prior to re-entry.
¿Cómo dejé eso Ariel Space ahí? ¡Qué
If you are
locura!
just joining us, NASA and SpaceX's 25th commercial resupply
No tengo
mission
perdón, no
launched
tengo
from
perdón.
Pad 39A at the Kennedy Space Center in Florida at 7:44 p.m. Central, 8:44 p.m. Eastern Time this evening, and is currently in orbit and heading to the International Space Station. Dragon is filled with over 5,800 pounds of cargo and supplies, including a variety of science investigations, hardware, and fresh food for the crew on station, such as apples, oranges, cherry tomatoes, onions, carrots,
tomate, naranjas, le lleva fruta fresca, qué bueno.
On board the International Space Station right now is the 7-person Expedition 67 crew, who I'm sure is looking forward to these fresh foods. The crew includes NASA astronaut Bob Hines, European Space Agency astronaut Samantha Cristoforetti, Roscosmos cosmonauts Denis Matveev, Oleg Artemyev, and Sergei Korsakov, as well as NASA astronauts Jessica Watkins and Kjell Lindgren.
¿Qué es lo que falta ahora? Bueno, que abra el cono. O sea, que nos muestran.
And we're just continuing to stand by on that nose cone deployment checkout.
Sí, estamos esperando justamente eso, que abra el cono y que lo confirmen. No sé si tendremos imágenes.
Dragon is slated to dock to the International Space Station on Saturday at approximately 10:20 a.m. Central Time. NASA astronauts Bob Hines and Jessica Watkins will be monitoring the approach of Dragon.
Si hay acoplamiento televisado, muy posiblemente lo hagamos
This week, NASA astronaut Bob Hines and Jessica Watkins spent some time reviewing procedures on a computer ahead of Dragon's automated rendezvous and docking. And the 2 flight engineers were also joined by NASA astronaut Kjell Lindgren, who helped stage cargo that
Lanzamiento espacial y misión redonda
at the end of
hasta
its
el momento.
months-long mission at the orbital lab.
Como nos tiene acostumbrados SpaceX y NASA, obviamente, ¿no? Falta ese momento nada más.
And we are continuing to stand by.
Uy, qué imagen, tenemos una imagen.
Checkouts are complete.
diciendo. Camilo Manzano dice gracias, me voy a ver. Gracias a ustedes por estar acá. Más tarde pasará por encima del centro de México, dice Fernando Catañón, y de la península ibérica una vez que dé el primer giro a la Tierra.
And we did hear that the first set of hooks is already
Se
driven,
transmite,
and the
si lo
second
transmiten,
set
lo
of hooks
hacemos.
is currently driving for that nose cone deployment.
Ah, ¿cómo no entraste? Lo cerré. Para un poquito.
All hooks are now open.
Bueno, dice que ahora sí está abierto el cono, ¿eh? Vamos a repetirlo. Vamos a repetirlo. Ya.
Everything continuing to go smoothly. We should have confirmation here just shortly that the nose cone is successfully deployed.
Estamos esperando la confirmación justamente de que el cono fue abierto o no. El dragón.
And we should have confirmation here shortly.
Vamos a tener la confirmación pronto, dice. Pobre, no le tiran datos. Música de suspenso. La cámara esta gira porque está siguiendo, seguramente.
And again, this nose cone
no
does
es el cono,
cover
es
the
el cono.
docking hardware as well as the navigation and
Es
rendezvous
el cono que se
sensors
está
and
abriendo.
4 forward bulkhead
Es el
Dracos.
cono. Se está abriendo el cono. Qué increíble.
And we're continuing to stand by for nose cone deployment.
Eso que vimos, estoy seguro.
And we did just hear confirmation that nose cone deployment is complete.
Sí, obviamente.
And with Dragon now safely on its way to the International Space Station and the nose cone successfully deployed, that will do it for us here in Mission Control Houston. Thanks so much for joining me tonight, but I hope you'll tune in for the docking coverage on Saturday, beginning at 9 a.m. Central, 10 a.m. Eastern Time. But for now, I'll send it back over to the Kennedy Space Center and Megan.
14 horas
Thanks so much
acoplamiento.
for walking us through that. That's going to wrap up our launch coverage of NASA's and SpaceX's 24.
Sábado, 14 horas UTC, 1400 va a ser el acoplamiento. Sí. Hay que hacer con esto. Vamos a repetirlo. Ya. Vamos a la repetición del lanzamiento. Volumen al máximo otra vez, ¿eh? Voy a disfrutar junto a ustedes.
Beautiful time of day to watch this launch if you're out on the beach.
T-minus 15.
And here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
Flight successful liftoff from the Kennedy Space Center, Launch Complex 39A. Falcon 9 is heading towards its next major milestone. That's the highest stresses that the vehicle will experience during ascent. There's the call out for maximum.
Se explotaron los micros, ¿no?
So from here, the stresses on the vehicle will get lower and lower.
¿Dónde están los motores Raptor? No, no tiene. Esto no tiene Raptor, Samuel.
Events back to back.
Los Raptors son de la Starship.
Engine cutoff, or MECO. That's where all 9 Merlin 1D engines on the first stage will shut down. Following that will be stage separation. The first and second stages will separate. The first stage will flip around to make sure it's headed back towards the landing site and our drone ship named a shortfall of gravitas. And then the second stage will ignite its Merlin vacuum engine to boost Dragon into low Earth orbit during second engine start number 1. We just heard the call out there for engine chill-in on the second stage engine starting. The last event is the boost back burn on the first stage. That's to reduce the velocity of that vehicle as we prepare for atmospheric entry. Now, all of those events happen over about 45 seconds, and again, they are main
Disfrutemos un poquito de esto que se termina.
Second stage engine start, and then boost back burn start. All those happening in just about 5 seconds.
Corte de motor, separación de etapas, encendido la segunda etapa, todo pasa casi junto.
MECO. Stage separation confirmed.
Miren el booster a la derecha ahora. Miren acá.
And back startup.
So the first 3 of those events are complete. Now, boost burn is underway. The shot on our screen right now is of the Merlin vacuum engine on the second stage. And as this view toggles, you may catch the first stage. It is firing its Merlin 1D engines that burn on the first stage, lasting about 30 seconds. You can see the plume on the first stage on the left-hand side of your screen as we're doing the boost back burn.
Stage 1 boost back shutdown.
Successful shutdown of the first stage Merlin engines for the boost back burn. Second stage engine.
Esta vez el giro lo hizo con motor y lo acaban de apagar.
Plus 8-minute and a 40-second mark into the mission. Now, you're just joining us, welcome to our 25th commercial resupply mission to the International Space Station for our customer NASA. You're watching our 30th mission of 2022 and the 3rd Dragon flight to the International Space Station this year. We lifted off just about 4 minutes ago from the Kennedy Space Center in Florida. On your screen are views of our first stage on the left-hand side of your screen, with its grid fins deployed periodically, controlling its attitude to make its way back home. On the right-hand side of your screen is a shot of the Merlin vacuum engine on the second stage, performing its burn. It'll continue to burn for about another 4 minutes to take Dragon up to low Earth orbit. Speaking
Lo voy a ver también varias veces
on the first stage, to make its way back to that drone ship, it's going to have to
Miguel Ángel Tete, llegate a replay, buenas noches.
the entry burn, where we'll ignite 3 of the Merlin engines, and that helps slow down the stage as we enter the upper part of the Earth's atmosphere. Following that, there will be a second burn, the landing burn, and there will only ignite a single Merlin 1D engine that'll bring the vehicle speed down to 0 for a soft touchdown on the drone ship. We've got some great sunlight on the vehicle, and you're periodically seeing some plumes of white. That's actually from our nitrogen gas thrusters that are helping to keep the first stage oriented, engines down, as we are in the vacuum of space at the moment. But once we get through that entry burn, the grid fins, which are deployed, you can see 2 of them on your screen, will then take over control as we start to get atmospheric authority. And then the first stage will only use those grid fins to steer back towards our drone ship. So entry burn expected to start about 10 seconds for now.
1 FTS is saved.
Just taking a quick look in stage 2 engine performance. About
El
nominal.
encendido motor.
Continuing to burn.
De izquierda.
3 more minutes.
Ese booster que viene cayendo, ahí está. Miren, de 4.700 kilómetros por hora que estaba.
You can see the velocity
Ya bajó
on the
1000.
stage, bottom left-hand side of your screen, rapidly slowing down as
Stage
we
1
fire
entry burn shut down.
the entry burn.
1.500 kilómetros por hora.
That burn only lasting about 15 seconds. And now we're doing a quick attitude correction to make sure we're pointing the heat shield down. And that entry burn and the plume coming back on the stage ends up depositing a small layer of carbon on the vehicle, which is what gives our first stages that awesome sooty look once we've reflown them. The Falcon 9 also has 4 landing legs. They're made of carbon fiber and aluminum honeycomb, placed around the base of the rocket, and they'll deploy just prior to landing during the landing burn. If we're successful in recovering this Falcon 9,
Ese aparato no estoy muy conocido de este tema.
and our 130th landing
Colocan, están llevando carga
overall
a la Estación Espacial Internacional.
including Falcon Heavy missions.
Y se viene el aterrizaje. No se lo pierdan.
So landing burn coming up shortly.
Stage 1 landing burn.
Keep an eye out on the speed.
Encendido de aterrizaje.
That's the stage. We're going to see that come all the way down to 0.
Miren las aletas como corrigen. Miren esas aletas.
Is our drone
Son
ship.
gigantes aparte esas aletas.
And also keep an eye out on the left-hand side of your
Pesan
screen for landing
1
leg.
tonelada cada una o más.
Stage 1 landing leg deploy.
People real excited behind me. Right in the middle, 5th landing for this Falcon 9, 130th landing overall for an orbital class rocket. Beautiful sight to see. Now coming up next is second engine cutoff number 1, or SECO 1. We'll expect the Merlin vacuum engine to stop firing just about 30 seconds from now. It's carrying
terminal guidance.
the Dragon spacecraft to its drop-off orbit.
El motor va a apagar en 30 segundos una vez que llegue a la órbita terminal con una velocidad de 27.000 kilómetros por hora. Sigue acelerando.
2 FTS is
We're
saved.
in the targeted orbit. We usually hear that called out as a nominal orbital insertion or a good orbit call out on the loops.
And back shutdown.
Okay. Y órbita nominal, porque aparte lo dijeron. Gracias por esa donación. No sé quién la hizo en la VIP de pasada nada más. Muchísimas gracias a las donaciones. Ahí está Ricardo Teje, debe ser.
There's nominal orbital insertion.
¿Quién aparece ahora en la lista? Aquí abajo. Muchas gracias, Ricardo.
And stage 2 is right where we want it to be. And of course, that also means that Dragon is right where we want it.
La verdad que es impresionante esto. No me canso de verlo. Lo voy a ver, no sé, 10 veces hoy. Recuerden, sábado, acoplamiento. Lo vamos a transmitir. Qué genial esto, ¿no? Qué genial. Me engancho y lo voy otra vez. Una más. Alguna más.
Power and telemetry nominal.
Una.
1, 5, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International Space Station with cool science and a new advanced instrument to more effectively study our planet's climate.
Debe ser de bajar el volumen. Quiero agradecerles enormemente el apoyo. Que igual están acá, que igual se prenden a pesar de que sigo sin voz. Ya estoy sin voz por el día. Estoy mejorando, créanlo. Ya lo vieron al principio. No puedo hablar, no debería hablar, no debería. Me engancho. Yo sé, soy un loco, pero no. Voy a cuidar, voy a seguir cuidándolos. En realidad no estoy hablando, Un abrazo enorme, gracias a todos los miembros VIP, los moderadores, los suscriptores, los que no se suscriben, igual no importa, pero por favor, háganlo. Así seguimos creciendo, así seguimos teniendo más transmisiones, más cosas, más espacio, más ciencia, más cohetes. Y se viene un encendido táctico en cuanto reparen esos motores Raptor ahí en Boca Chica de la Starship, es lo que se viene. Y el SLS, esto es imparable, ¿no? Y con esa imagen nos vamos. Un abrazo enorme, gracias. Coti, teletranspórtame, por favor. Café. Lo dejo con esta imagen. Nebulosa Karina, vista por el James Webb.